Okay, we are live. Hello, everyone. This is Nikolai, Postgres TV, and today we have very interesting guests, Joseph Sciarrino and Jonathan Dance, right? Sorry if I pronounced wrong. Thank you for coming.
Oh, thanks for having us. No, those were perfect pronunciations. Yeah.
Great, thank you. And as your T-shirt suggests, we will be talking about Hydra, which is a very new Postgres-based product. And you call it open source Snowflake, right?
Yeah, we're looking to build an open source alternative to Snowflake, and really, there's no better place to do that from the Postgres community that we love.
Yeah, this is interesting, and I will ask about this based on Postgres using several angles. But first, can you describe why do you do this? Like why you decided to create this particular product, and why the name? Why Hydra?
Yeah, sure. I could start there, and then JD, always feel free to jump in. So we felt that the status quo for data warehousing doesn't really work for everyone. Postgres has always been built on open source, accessible, run it yourself if you so choose. We didn't really see that in the market for data warehousing. The data warehouse is a kind of big, heavyweight, expensive, enterprise geared data product. We felt like, okay, let's try and take Postgres, which most people start with and use today, and add, solve for the Achilles heel of Postgres, which is analytics. When the data and the indexes no longer fit in memory, Postgres, generally tends to slow down. So can we bring big data to Postgres was really, really the question. As for the name Hydra, I think it really came off of an architectural diagram where we were looking at many data sources all coming to a singular point. And so that kind of looks like that multi-headed, mythological creature. So that's how we came to the name.
Sounds like you are definitely using foreign data wrappers, right? To get data from different sources, or some random technical question. Do you or?
I think we're agnostic, right? Because you can get data into the data warehouse via pipelines, but also you can use data wrappers too. Not just the data movement, but querying, remote tables would be done via, foreign data wrappers. Exactly.
Mm-hmm, mm-hmm. Okay. Interesting. Postgres. Okay, but Postgres is raw store, right? And you said when it does fit memory, obviously everyone knows that count in Postgres is very slow, super slow. So how do you solve this problem?
Yeah, the main thing that we're adding to Postgres is a columnar store. That is the really first key technology that you need in a data warehouse. So that was something that we saw as an opportunity to say that that's really missing in commercialized Postgres is a columnar store. So the first step was to bring that to market, and since then we've been working to make that faster, better, and we're looking to continue to do that.
Right. I've read your blog posts and the general overview, and it looks like three components of your product. Key components is parallelization, column store, and vectorization. Right. So like three. Am I right here?
Yeah. So the thing that we added in this last quarter, in this last release, is parallelization for columnar, which really had a really, even for us, a surprising impact, from where we were before. So, obviously it's very important to use all the resources that the computer has, all your cores and things like that.
Yeah.
So that helps a lot. But yeah, the key ways to make things fast in the data warehouse, beyond just obviously how you store the data, is to parallelize things, and then to really start tapping into vectorization. So columnar data is stored in such a way that vectorization is kind of the next the next step you want to do because it's all the data is together that you want to compute on. So far we've vectorized filters. One of the big projects left to do is to vectorize like aggregates. We've done some experimental work on that, but it's
yeah.
not.
But I think columnar maybe is the most interesting. I will return in a moment to this topic. But about parallelization, is it somehow? I agree that it's very needed for analytical workloads, and these days we can get machines with hundreds of cores, so we definitely want to run it. To run many to parallelize our work. But how is it different from Postgres, like so-called vanilla Postgres? It already has parallelization, right? Like selects can be parallelized, a lot of things are already parallelized, and each release gets new improvement, almost each release. So is it the same but applied to columnar, or something like some secret sauce there as well?
Our bread and butter is really leveraging the power of Postgres, right? So what we needed to do from an engineering perspective was implement things in such a way such that the Postgres engine could parallelize columnar. So that had not been done in the past. So in our first release, basically. So at least for now, the parallelization engine is predominantly powered by Postgres, but you have to work with the Postgres APIs and actually go implement that. It's not quite as I don't know, it doesn't just come out of the box, I guess is what I'm saying. But the main technology now, as far as like how the parallelization is organized, is done by Postgres. It's like the Postgres workers.
All right. So you join several things and benefit from like, how to say, from them working together as one piece, right? Exactly. Okay, I see. By the way, we have a couple of questions in chat. This is great. Only few people. I will return to them later a little bit. This is great because we usually like only a couple of % of views are generated by users who watch online, but these users are the most the best for us because we can ask questions. But let's say it again.
Thanks for tuning in, everyone.
Yeah, thank you. Indeed, this is great that we will have questions from audience. But I as being host, I can ask questions before, right? So my question is about columnar. This is very interesting. First of all, I remember some attempt from Cytos to create this, and I remember it was based on FDW, probably because at that time we didn't have table access methods generalized, right? So it was not natural to bring columnar storage to Postgres. And I've checked your source code. I saw Cytos many times in source code, right? But at the same time, I saw table access methods mentioned. So probably you don't use FDW anymore for that, right? Can you explain some technical details about your also like side question, license? Because you claim you're Apache 2.0, but if you go into columnar folder, it says AGPL, which is not Apache compatible. So probably it's because your product is quite new. So I have a bunch of questions related to columnar. Can you explain everything at once? Because I'm very interested to know about it.
Yeah, of course. So, we not trying to hide anything here. The first version of columnar was a fork of the Citus columnar method, and we looked at that, said this has a lot of potential, but also has a long way to go. But that was our starting point. So Citus did have a version of their columnar store that did use the access method API. So it wasn't a foreign data wrapper anymore. That was the predecessor project. But the things it didn't do obviously was parallelize queries, and it didn't, it doesn't have updates or deletes, which is our next release. So we're very excited about that.
One second. Yeah. So right now you don't support updates and deletes, but in the next release you are going to support them, right?
Yes.
And just like to compare with ClickHouse, I'm very lagging in understanding ClickHouse features, but I remember they didn't also support it, but always promised. I don't know if they support it now. Like, do they? Like, because of course ClickHouse is kind like I'm very excited because of course Postgres support of SQL is like huge, right? So if you have it in analytical database system, it's great. But also this like deletes updates are usually not fully supported or with like some all not supported at all. So as you
can imagine, this was our most requested feature by our users, right? We participated in Y Combinator earlier this year, and I think they're famous for build things people want, make things useful that people want, and support for updates and deletes, like JD said, is really exciting part of our next release. And then in terms of the Citus columnar piece, I also do want to mention that I previously worked at Citus Data. Right. So I was with the Citus team that was acquired by Microsoft. I spent the last couple of years at Microsoft as a PM supporting Citus and Postgres generally at Azure. So certainly this was one of the first places to look, given past experience.
Good. So and does ClickHouse support deletes and updates these days, or goes? Yeah, it does, right?
It does. I don't know too much of the details or the performance.
Okay,
characteristics.
It's
obviously
different.
Very focused on what we're doing, but
of course.
Worked a bunch with the ClickBench, which is their like open benchmark stuff.
We will return to ClickBench because I have many questions to your benchmarks published. Right?
But yeah, that doesn't test update. It's just reads is how ClickBench works. So yeah, the updates and deletes is just sort of a nice to have, I guess, from their perspective.
Right. So okay, let me return to questions which I feel don't covered yet. So about licensing, this columnar part of your product, it's AGPL.
Yeah, I'm sorry if there was any confusion there. I actually updated the README, I think on Friday, just to clarify this. We used to have the columnar source code in a separate repo, and so there are some things that need to be updated there.
It will remain on AGPL, right?
Yeah, we can't change that. So yeah, it's AGPL. And it is an extension of Postgres, so it remains kind of separate. What the Hydra repo does is build a Docker image that you can then run. So there's code in there that is part of the orchestration of the Docker image. There's code in there for the other things that we add to the Docker image, like foreign data wrappers. So all the code in there that's not the columnar engine is Apache. So everything that we've contributed.
Why not AGPL, by the way? Why Apache?
I don't know. That's a good question. AGPL is a very sticky license. But yeah, the code that we've written really that supports this stuff is not the most important part is the columnar engine, I guess, is like the end of the day, right? So because
analytical database system should be columnar, because it should have very fast aggregates.
Right.
Exactly.
Yeah, we just we needed a license, and it's like, okay, like there's nothing, so to say, there's nothing in there that's like super secret sauce or anything like that, so yeah, as far as the glue around it. So
yeah, I think part of the DNA just of Hydra, from day one has been, make great things and then let people use them. So I hope that our licensing will always continue with that in mind. Now, obviously, there's some things you need to do in order to protect like a commercial venture, a commercialization of open source, right? But at the same point, just make good stuff, give it away, share it with people. I think that's the starting place.
Yeah, I have tough challenge here because our discussion can go in different paths here. I think I will stick to technical one. in this case, because of course, like business model and so on, it's super interesting to me. But let me ask questions from chat. They are about, first question is about vectorized processing, and do you have to rewrite add a lot of Postgres operators, optimizer to take advantage of vectorized processing? So this is the third part. Like, so first is column store, second is parallelization, and third and vectorized processing. So did you need to change a lot in Postgres to get benefit from this?
So it would be a best question for my database engineer, but I think I get the hint of the question, which we actually did experiment with that, and we may revisit it, where you basically rewrite the operators, and that's something that I think we will revisit at some point. But the vectorization we have right now is vectorization of filters, so that happens within the storage engine, I believe, rather than on the compute side. But we did experiment with having custom nodes that then replace the types and vectorize the types and all that.
And vectorization for our audience is just when we run multiple steps at the same time, which should be running usually one like after another, right? Can you explain what vectorization is?
Yeah, so it's the process of computing multiple things together at once. So, and actually, like, it's basically processing a array or vector of information all at once. So instead of going row by row and adding up, say you're summing, right? Adding up every row and going across each row this way. In columnar, obviously you already have the data in columns the other way, and vectorization is doing the computation of a particular, effectively a column all at once. And the idea here is that your memory access is much faster because you're accessing data that's close together. And the other thing is your modern CPU has these special machine things called SIMD or SIMD that basically allows you to pass chunks of data to it and say, add this up for me. So rather than having the code do a loop, you can pass this in chunks to the processor. And that's kind of the final step of having vectorization is using SIMD.
And for final result, how much benefit it could get?
Yeah, obviously there's like the ideal case. I think in like a simple sum, not doing anything else, I think you can see possibly as much as like 10x increase. But again, it's something we're still experimenting with. The vectorization we do right now is the filter clauses. I don't have a before and after of like how much that helped with filtering, unfortunately, but
filter, you mean in select clause? Oh, filter, I mean where clause or select where clause?
Sorry,
because in select you also can have filter and then in parentheses where, so it's different. Right?
Yeah.
Okay.
But just to underline that point. So there's a lot that's been done, and there's a lot actually left to do. So I think we're starting from a really great performance baseline. We're going to get into our benchmarks, I'm sure, that showed that by adding columnar and query parallelization and vectorization on where clauses, we're able to see really good analytic performance. And this is without SIMD and many of the additional things that we're going to do later. So kind of excited to see where it goes from here.
Yeah, right. Well, I understand that this is only the beginning and a lot of things can be done. And I especially noticed how you trying to work together with other products and companies. I noticed like we are integrated with this. So this is great. I think it's the right approach. But speaking of benchmarks, as I understand, you chose ClickBench, right, from ClickHouse, comparing various analytical database systems. and you claim that you're the best. You did it synchronously, so showing that founders are synchronized.
Yeah, we have a parallelization. Yeah.
So question is, I saw the results. It's the latest blog post, and it was actively discussed on Hacker News. Very, very interesting. But I've noticed that probably it's not your fault, but I've noticed that machine was not big. Like it's very moderate instance on AWS, and also database size. It fits to shared buffers. So it's not an analytical approach. You mentioned database doesn't fit memory, right? So
Yes.
what's happening here? Why we are checking everything in memory case? Not we have 20 terabytes, but only 700 gigabytes of memory, right?
Yeah. Well, we didn't design the test, which I think it's good. It's a starting base that we didn't.
You kind of take off industry de facto standard, right?
Yeah, ClickBench is nice because it's a easy to run test that's been standardized and the results have been shared widely. Comparing to something with like TBCDS or TBCH and those kinds of things, it's a lot more difficult to run. There's not really a good place where those results are aggregated together. And those tests take a lot longer to run. So yeah, we liked ClickBench just for its kind of simplicity. But yeah, the data set it's a 100 gigabyte data set, but columnar is also compressed. So when you, which you do for a lot of different reasons, obviously it takes up less space on disk, but also means that, yeah, you can, not the shared buffers, but actually the Linux buffers, you get more use out of it because it's compressed. You can go further with how much data is cached. So once the data is compressed, yes, in theory, it does fit in memory. In practice, you can look at the cold versus hot run on ClickBench. It doesn't make a huge difference, surprisingly. I guess with the speed of disks these days, the I/O and reading it into disk, it's.
Let me disagree here with you. Even NVMe
it definitely makes a difference, but
it's still much slower than RAM. So.
Oh yeah.
So,
but yeah, there's a lot of, there's a lot more that's happening in a query than just reading the data off disk.
Let me show these results. So I don't remember how much RAM it has. This machine probably
32 gigabytes, I think.
Yeah, just 32. It's not analytical database. I mean, I would even small company would take bigger machine, I guess. But okay.
We give. In our product, we use the memory optimized ones rather than the compute optimized ones. But again,
well, of course, right.
This is the instance size that everyone was testing with on ClickBench.
This is strange. Why do they do it? Or probably we should ask Milavida or like ClickHouse guys, right? So it's very strange. And database size always fits it. So it's
one thing also to point out was even before we released these benchmarks, I think ClickBench folks were in our repo asking for us to release these benchmarks. So they were asked for, and we have delivered them. We have delivered them here. So they're very on top of it, I think. And so we to JD's point, yeah, we just kind of, as much as possible, standardized to what everyone else was testing and using, so that it was close to apples as that's when the benchmark is really actually useful. As opposed to even just us designing a separate benchmark.
I would say this is an edge case in terms of analytical workloads, because it's not what we usually have. Usually we don't have memory. Like enough memory to load, to cache everything, right? So, but colors are impressing. So, in the beginning of this blog post, you are comparing to timescale and others, and it's much better, right? So it's impressing, it's good, and of course, I think it's because of first of all columnar, right?
Well, you can see if you go, if you go back to the graph, we included site as columnar on there, and that's without, you can think of that as what we were more or less running before. So there's quite a bit of an improvement from the
significant
parallelization.
improvement.
Yeah, quite a bit of an improvement from parallelization. And when JD was saying we were surprised, he wasn't kidding. Yeah.
Have you checked for like, I don't know, like 10 terabytes or something, or you only it's in plans?
We haven't run a benchmark against 10 terabytes now.
Okay.
We would have to, of course, run a benchmark of something else to have to compare it to as well. But yeah, I mean, it'd be interesting to see how, like, take ClickBench and 10x the data. How would each of these engines perform?
Yeah.
Yeah, I think you would definitely see some varied results.
Right. Let me ask questions from chat at this point. I will shuffle them a little bit. Any interest in column store compression?
Yeah, we did it. No, actually,
we did it.
It came. I should say we have it, but that was something that the Citus columnar engine has as well. So we didn't have any work to do there, so that's nice. Again, the benefits of open source and building on Postgres.
Yeah, and from this, sorry.
Oh, I was just going to say, you can run it and load some data and kind of see what your compression is. It does vary like case by case, right? But generally speaking, maybe you should expect to see 5x data compression.
What kind of compression is that? Is it dictionary based or compression or something? Like additional question from chat. Thank you for questions.
LZ4.
Is it 4? So okay. If we talk about previous question from the same person, thank you again for questions. So if we talk about columnar, we need to choose to make this decision at table level, right? Not at column level. So we cannot have, so we would say, okay, this table is columnar, right? So it's quite limiting. Not limiting, but recently, maybe Google Cloud released AlloyDB, which is quite interesting. They have row store and combined with column store in memory. So, like, what do you think about this approach, like hybrid approach?
No, I think that's great. What we strive for as well is to really do 3 things with our product. It's to be fast, it's to be simple to use, and it's to be open source and kind of low cost, right? So the things that we can do to make the product simpler for users is really important to us, and it's something that we're looking at. Right now, you would look and see, okay, I have this large fact table, and that should probably be in columnar. There are some pretty easy conclusions that you can draw. And as well, we have a public Discord and Slack as well that folks can join if they have questions for us. We're always happy to help out with the data modeling. But it pretty much just aligns to what people do with data warehousing generally.
Yeah, it makes sense. AlloyDB is definitely not very open, right? But at this point, I cannot not to ask a question about your business model. So, are you going to build some cloud offering, or how are you going to make money?
Yeah, so we have a cloud offering, and you can get a 14-day free trial, actually, if you so would like to test it. So our cloud offering is, classic managed service, Postgres, essentially, backups, HA, disaster recovery, all those kinds of things. It's built on top of AWS. In the future, of course, we plan to support additional clouds. I think that's one of the key pieces here too, is, the flexibility to change providers. If you get married into BigQuery or Redshift or, I guess AlloyDB, you're kind of committing in some part to that cloud, or at least it's harder to get out of. Whereas with Hydra and similar to Snowflake, it's kind of multi-cloud offerings of the warehouse. I think that's important because the decisions that you make earlier in a business certainly might not carry through after 10 years.
Right. So okay, and that's interesting. But like, how do you control this? Like, I can install everything myself, right? So how do you expect people to make this decision to choose cloud over self-hosted open source version of Hydra?
Sure. One thing to point out is JD and I met while we worked at Heroku together. So we are certainly of the camp of life is too short to be self-managing your own databases. You should really let us do that for you. So, of course you can run it yourself, and that's really a beautiful thing. But also, the ops is where value isn't created for your users. That's something that we can help out with. And, I hope you'll give our cloud service a try.
But in this case, why do you keep it open?
Why do we keep Hydra open?
Right.
No reason not to. I think, the idea that you could run it yourself is still very attractive. You can also run it locally. You can do local testing and have that environment there as well.
And obviously, we only support AWS right now. If you have a need to go run in OpenShift or Google or something like that, you can certainly go do that.
Or bare metal, some people.
Or bare metal, on-prem. There's a lot of use cases that, open source, you can really enable. And it means that you're also not locked into our service. There's a very easy off-ramp, if that's what you end up needing, right? So it's nice to always have that option of saying like, oh yeah, I could run this myself if I needed to.
Right. Yesterday I saw on Twitter some people discussed that it's a big idea that to create something like Tableau 2.0. So there is a huge demand in new tools for like analysis and so on. What do you think about it? Do you have plans to create something, or you have plans to integrate with some products or companies or in this area, because it's very close to your area, right? To your field.
Yeah, that's a good strategic question. Our preference is always to work with partners that care a lot about those categories of products. So, for example, today you'll see a Metabase post that is sharing the Hydra connector that they have with our service. We really prefer to work together and not try to create this monopolistic data platform where we control every little piece of every little tool. I think there's a lot of beauty in the ecosystem for data pipelines, ecosystem for BI and analytics tools. And yeah, we want to work really closely together with these partners. Hearkening back again to JD and I's experience at Heroku, one of the great things about Heroku was you could just use the tools that you want to use more or less, because it had this really robust add-ons ecosystem. There's a lot of things that the early Heroku team did super well that have been at this point generally, commoditized table stakes in the industry at this point. But, the idea that you can just use whatever tools you want to use and you're not going to get like tied into Hydra primary services is really important for us. Yeah.
Mm-hmm. And a question about like how if I choose between Snowflake and like open source Snowflake Hydra, how do you see this decision to be made, and maybe in favor of your product, of course? So
yeah, absolutely. I think that, based on where we are right now, to be totally clear, our service isn't prepared to handle like a 4 petabyte workload on Hydra. So, if you're of that size of Boeing or and you have some major data to put on the warehouse, maybe give us a year or two to get there. But for everyone else that's building off of Postgres, I would ask you to take a look at our service, which starts at basically half the cost of Snowflake or other ones. so that you're able to really get going at a reasonable, fair price. And you're able to use the familiar tooling and syntax and ecosystem that you know already with Postgres. So you don't need to kind of leave that environment, go to something else.
Everything from Postgres is supported, like recursive CTE, window functions, everything, right? So everything is supported on Hydra. It's not like I remember on Cytos earlier days, for example, recursive CTE were not supported, right? So in your case, everything is supported, all syntax.
I think,
there are some
Should
things
be
in
so.
the columnar engine that are not supported yet, but most of those revolve around the updates and deletes. So as we add support for updates and deletes, some of those things will come along with it. But yeah, as far as like computational type things, that's the beauty of Postgres here is you get
select statement is fully supported and with statement.
Select, yes.
Both statements. Okay. Yeah, that's great. That's great. And this is a big advantage over Snowflake, definitely, because of course, Postgres implementation of SQL, it's huge. It's huge. Okay, great.
A little different. Yeah.
Some points, yes, but still. I also wanted to ask you about, we discussed FDW a little bit, but what about CDC and like pulling data from various sources and so on? For example, if I have already Postgres, I think about like at some point I grow, and at some point I need analytical separate database system because running very long queries on production, even on standby nodes, it's very bad, as we know, because you need to choose hosted by feedback on off, and both choices are bad, right? So you need at some point, and also of course aggregates are slow, definitely. So because it's raw store. And at some point I need to choose, okay, ClickHouse or Snowflake, or okay, Hydra. It's like close to my ecosystem, Postgres. I love Postgres. I choose Hydra. But how to bring data, and not just bring once, but continuously bringing it, right? So CDC, logical decoding, and so on. What can you tell us here? Because there are limitations. For example, I need to use only primary node, right? And always I cannot bring data from archives or from even standby nodes. So it's always from primary. If I want very small lag, right? What do you think about this? Is it something that you are also working in, or maybe it's something like postponing this question? Or
yeah, the main thing that, excuse me, sorry. The main thing we're looking here is to work with again ecosystem partners. You can use pipeline companies, and they generally, most of them do support
pipeline companies. It's like Click, former Affinity, Affinity. I don't remember. Click. There is Click company they renamed, and also Fivetran, right? These kinds of
companies like Fivetran.
Fivetran. You mentioned it in the documentation.
Airbyte, yeah.
There's
I remember funny experience with Fivetran. I have quite huge customer, I would say, on AWS, and we tried to use Fivetran, but it's interesting how people can trust data to some pipeline companies, production data coming from OLTP database to analytical database, and you trust it to some which just they have your all your production data. Interesting. But I remember a funny thing, they had servers running on GCP only, but we needed like to work with AWS, and they fell. It was like 3-4 years ago, but now they run on AWS as well, so it's not a problem at all. So basically you're limited by latency between clouds, and it's not good at all in terms of throughput as well. But okay, so you are integrated with Fivetran, as I remember from documentation. You can integrate with Fivetran.
Yeah, they have a Postgres destination, which means they have a Hydra destination.
Right.
Yeah, there are a lot of different options out there for this, and
Debezium also, right? Like true open source approach. Debezium.
Yeah, and tools like Conduit, things like that. And yeah, we're looking into, possibly trying to make this easier for our customers, having a built-in option. And yeah, coming from Postgres, obviously there's a lot of familiarity with using logical replication, and can you tap into that more directly? Yeah, it is
It's
something
logical replication, not decoding. So you can use logical replication because you're also Postgres, right?
Right.
So
Yes.
interesting. Good. It's good. But limitations, like what about limitations? Do you think about them, or it's too far from, like, you have a lot of things to do already? I mean, this is the need to work with primary, for example, or like some various limitations in terms of, like, if you have a lot of TPS, you hit some settings, some limits.
Yeah. It's not, personally, it's not something that we've run into, but it's something that we would obviously work with the customer on whatever issues they're running into. But I mean, yeah, my instinct says that you would want to try to run it off the secondary. Generally the latency to a data warehouse is not quite as critical as it is an OLTP. So you can usually take a slightly more relaxed approach on some of this stuff and try to take advantage of doing stuff in batches or what have you. Obviously logical replication doesn't really work that way. So
you can parallelize it, but it will, like, you can have multiple slots on the source. So
right.
latency, like, you can improve throughput, but as remember, wall sender can hit 100% of CPU, and parallelization won't work there. So all your workers will be 100%. So it's not good if you hit this limit.
Yeah. Yeah, I know some of the pipelines out there use it and some of them don't. It's also something, you can choose to use, but yeah, the trade-off, of course, is comes down to latency on what you can tolerate as far as how often you need to bring data into your data warehouse.
Yeah. So good. Maybe one of the last questions. Like, guys, I see your questions in the chat. Thank you so much. I think we covered almost everything. Correct me if I'm wrong. And one of the last questions. So we have opportunity to before we wrap up, we have opportunity to ask several questions. One of the last questions is from me. I asked it on your GitHub in discussions about sharding. So if you are both from Cytos or from, you're not
just
from Heroku. Sorry. Only one of you from Cytos, but you took something from Cytos. Definitely, sharding is one thing that probably we should have in anyway. Like, again, I understand it's too early, not petabyte scale yet, but in the future, when we will have to think about petabyte scale, what are your plans about sharding and scaling in general if you have a lot of data?
Yeah, I think the thing to remember is, we want to commit to solving, falling in love with the problem that we're solving, not the technology that we think will get us there. So the point being is, could be sharding, could be other approaches. I think it's too early to really commit.
What are the other approaches? In terms of analytical database system, what are the other approaches except sharding? We cannot have microservices here, right? We cannot split everything to different vertical like services here. So what else except of sharding?
Yeah, I mean, I think sharding is very important. The thing that, and it's something that, right now we don't separate compute from storage, but that's definitely something that we want to pursue. And separating compute from storage can mean that you're effectively sharding the storage side of things, and then you can potentially push down computation, or at least like filtering down to the storage layer.
Interesting. I see it very differently, but maybe you're right. I need to think. So far, I thought it's very like orthogonal approaches, but okay, I might be very wrong here. So I'm not a sharding expert at all. I'm very OLTP guy, like old school and so on. So
yeah, that's kind of the approach that we think that we want to take in the coming years.
Like keep all data in S3, for example, if it's AWS, and then to load it lazily in background and like Neon, similar to Neon, or
yeah, using S3 as a backing store. Obviously, you can't really do much with the data in S3, but that's kind of where your durability comes from, and that sort of thing. And then, yeah, loading data onto something as an intermediate where that's where the system can access the data. But even that can still be distributed across multiple systems. So yeah, that's kind of the direction that I have in mind. It's not something we've put to code yet, but
right now you use, as I remember, you use Spilo from Zalando, German, because German company, and WolG, originally from Citus, but currently supported by many Russian people and so on, right? So WolG, you use WolG, right?
yes,
that's your technical stack. Yeah, that's good. We also use it a lot.
Service. Yeah.
But that's interesting thought. To separation should help with scaling, maybe. Again, I need to think about it. Sorry, but it's interesting. Okay, maybe one of last questions from chat. It's not me asking about license once again. Why not use the Postgres license? The way the improvements can eventually be integrated into the Postgres itself. Is this not really wanted business model? Like I'm not fully understand the question, but why are you not on Postgres license? Why Apache?
In part where we have to use the AGPL because it's a fork of Citus columnar, so we don't have a lot of choice there. As we go forward and develop potentially more of our own technologies, we'll be able to make our own choices there. I think we do have to think about, the commercialization aspect and whether we go full open or we use something else. But yeah, I definitely think about that a lot as far as like contributing back to Postgres. I think if there's things that we find that we can contribute back to Postgres, we're also, whether it's Postgres or, we send a PR to Spilo last week, like, we want to definitely get back.
You cannot send PR to Postgres, unfortunately. You need to deal with div, patch, email attachments, and so on.
Conceptually, a PR.
Yeah, well, it's a big question we discuss always, but I mean, in small circles, but yeah.
Yeah, and we know several Postgres committers, so we could talk to them about like what's the right approach and how to do that. But I think the bigger question for something like Postgres and open source for something like this would be, okay, would Postgres want a built-in columnar store and then getting into the OLAP space? Is that something best left to a commercial entity, or is that something that the open source project wants to take on? I'm not sure. That may be the eventuality, but with Postgres mostly being focused on OLTP and row based, it's to worry about things like vectorization and columnar store and all that is a very different approach.
Yes, this triggers technical question in my mind. So we discussed that, okay, we need to make choice at table level, this contribution. So if I have tables, regular Postgres row store, and I have several tables for analytical purposes, probably we'll need to have some materialized view, which should be incremental and so on. Like there is a big unsolved problem, right? So did you think about this direction? How to improve materialized views in Postgres? Because I think it's also close to your field, right?
Yeah. Materialized views are something that are hugely useful. But obviously, you have to decide on how to update them, or
they are very rough. these days.
Yeah, they seem great initially, and then, oh, well, I have to worry about keeping them up to date and all that sort of thing. It's definitely something that it's not something we've looked into yet, but it's definitely something that, we would
Incrementally
consider.
updated materialized use, right?
Yeah,
that would
it's
be huge.
something. Yeah, it's something that I'm concerned now that you have like a secret microphone in our roadmap meeting.
Yeah,
You're using the exact terminology.
I'm a Postgres guy
yeah.
with 18 years
Yeah.
of experience, so it's easy for me to understand what problems you have on your table. It's really like not difficult. There are several attempts to solve this problem, but not ideal, all of them.
Yeah, I mean, one thing we could do for at least, in the interim, it'd be like offer an integration with Ready Set or something like that, where you effectively get the feature, but it is something that you have to manage a lot more than, just say, yes, I want it to be incremental and magic.
But this is something that should be in Postgres, in my opinion. This company called Materialize, which had interesting thoughts as well, but they immediately wanted to commercialize this, right? And also there is IVM or something, which has also a lot of limitations. So it's interesting. I'm very interested in this because all my customers and people who I help to, they always try like, oh, we have materialized use, and like full run to this, and then like refresh concurrently, then bloat there, and like a lot of issues because of lack of incremental updates. But you can do it if you can afford advanced coding. You can do a lot of yourself, like you can implement a lot of things yourself, and there are recipes described in wiki, in blog posts. Yeah. So okay.
Well, I think one of the really beautiful things about Postgres just generally is that it's very much like a multi-tool, and you can use it in many different kinds of scenarios in many different ways.
Exactly.
Now, workload-wise, right? I think Postgres has been oriented around OLTP. It's probably not going to change, but we really do hope that with our work at Hydra, that we're able to at least shift the conversation a little bit where, we begin to think about and contribute more on the analytical side of the house. I don't think that staying with just OLTP workloads will be enough, especially as we see like data warehouse providers like Snowflake and others beginning to add like transactional support like Unistore to their warehouse. There's going to be a whole new category of apps that we're already seeing called data apps, which are built directly on top of the warehouse itself. And not all of these apps will be pure OLAP reporting apps. Like there will be need for transactional throughput on these type of warehouse native applications, right? I think that this is where Postgres really has a big role to play in data warehousing, right? We're bringing, what's been contributed over, standing on the shoulders of giants, right, over 20 years to bring, all these features, functions, transactional capabilities into the OLAP side of the market.
So you think
meeting somewhere in the middle? Yeah.
Postgres can be a perfect H-step system at some point. Maybe H-step, I mean hybrid.
Yeah. I think that HTAP definitely still is coming to mainstream. But yeah, Postgres has its role to play in HTAP for sure.
Yeah, I enjoy this conversation so much. I can stop. Like, let's try to like 3 more questions, and that's it. How faster select count on some, like, okay, index only scan. That's it. Like, it's fully. We have visibility map updated. Everything is quite good on Postgres versus Hydra, column store. How roughly how much faster it can be?
Everyone loves the count query.
Count is like Postgres is blamed for count for decades already, for slow count.
Yeah. Again, I don't have a number in front of me.
10, 100, 5, 2.
I think you can see it in the very first ClickBench query is a count star from.
Okay, I can open it.
The beta thing. So I think if you compared Hydra to just raw Postgres, the columnar helps, parallelization helps.
This one, Q0 or?
Right. So so if you hover over Q0, you should be able to see Oh, sorry, this is on our blog post. You have to actually click.
If you scroll down, yeah, if you scroll down the page, you'll see where we link to the actual benchmark.
Source code? No.
Or is this up top? Actually, sorry, keep going. It's up. I got confused.
Back?
Yeah.
Click bench, methodology.
Oh, yeah. Jump to full. Okay. It's not here. No, it should be here.
It is here.
But it's here. Let me. Where? Here?
Yeah, that link, I believe. Oh,
it's just.
See results for yourself. That's it. Thanks. Our own blog post.
And here we can hover. You said. No, it doesn't work. But you are sure
anyway,
this is count,
0
right?
is select count start from hit. So you can see, the the speed up is apparently 500 times compared to just regular Postgres in a row table. So yeah, it makes quite a big difference.
Yeah. I wonder about details, of course, like was it fully vacuumed everything and so on, but maybe it's too much like for a Zoom call, of course. I would dive into details here, but okay. So it's faster, definitely, because it's column store. As expected. Also, I think it depends on the width of table. If the table is huge in terms of many columns, toasted very heavily, column store will benefit much more, I think. And also,
it is a very wide table.
I think maybe you even lost here in terms of this ratio. If you had database size much bigger, not fitting to memory, probably this ratio would be much more impressive. Right? Maybe.
Yeah, potentially. And I think there's, there's still more, we can do.
Yeah, of course. Well, first results, completely understandable. So, okay, I lost window of chat. Sorry, 1 second. Couple of last questions, and we will finish. So, again, about benchmarks, HPC-H, larger scale sizes, we already touched this topic. Anything to add? Like you are planning to do it, right? So
yeah,
with larger
I
scale.
think I totally agree that having something on a larger database would be great. And we already use, I think, TBCDS for just internal testing of making sure that all the queries work as expected and that sort of thing. So the TBC benchmarks are definitely something that we're looking at. And I think we'll continue to run ClickBench as well, but and update it as we go forward. But yeah, to your point, something that is on a larger data set would be nice.
I definitely want to ask ClickHouse guys why they use so small data volumes and small instances and so on. Why, like, maybe there is maybe reason behind it. So I just don't understand it. Okay, maybe last question.
One last thing on the benchmarks. Yeah, we'd also love to see transactions per second comparison between Hydra versus traditional warehouses. This is another thing, right? We talked about HTAP, right? So
I understand that.
I think that's definitely a favorable comparison for sure.
Yeah, that makes sense. The numbers should be much better in terms of throughput, TPS, QPS, right. So, okay, last question. Anything you can suggest people where to start from to try Hydra and work with it? What to do?
Yeah, absolutely. I think the easiest thing is, we make our open source like Docker right there. It's lightweight. It's just a drop-in replacement for the Postgres Docker. So, I mean, that's going to be super simple to use. But in addition to that, like I mentioned earlier, we have a 14-day free trial of our cloud service. So even if you just want to spin up a trial, kick the tires with it and see how it works in the cloud, you can certainly do that without even having to pay us anything. So that might be the easiest of all.
Any limitations in terms of data volumes there?
It's a 100 gigabyte disk, so you could store up to, it depends on what you're storing with the compression, but anywhere between half to a full terabyte on the demo.
Mm-hmm. Good. Okay.
Underlying data, uncompressed data.
Right. Okay, guys. Joe and JD, enjoyed it a lot. Like maybe this is the best interview I had in Postgres TV. Live like I just so many questions, and it's so interesting what you are doing. I will definitely try it when I have opportunity. Encourage all people try and provide feedback. Where to provide feedback, on GitHub or where? What's the best? Discord you mentioned, right?
Yeah, we have a Discord. We have those GitHub discussions as well. We need to keep better tabs on those, to be honest. But yeah, we can definitely engage there. You're also welcome to open an issue if there's something more technical that you're running into. Yeah, we're really open to all the channels. Yeah, and we're also, if you really want to get engaged, we're also hiring. So looking for people from working on sort of the more front end side all the way to the Postgres side. So
you graduated from YC. It was Citus, probably one of maybe the first Postgres company, then Supabase, and you're the third, right? I'm just keeping track. Postgres companies from YC, Y Combinator.
That
right?
could
Three
be
companies?
that could be correct. That could be correct.
Yeah.
I'm not 100% sure, but it sounds right to me.
Good. Well, good luck. Good luck. I'm excited that more new directions based on Postgres are opening. So it's very great. I hope I will try definitely, and probably we will also cross our paths at some point, maybe somewhere. Thank you guys who watched this online. Those who watch recorded, please ask questions. Don't forget like button, subscribe, and so on as usual. Bell button, all the buttons. And again, good luck. Thank you for this wonderful interview. Thank you.
Thank you for having us. Yeah, we'll be at Postgres events throughout the year. So if you ever see us, come up and say hi and tell us you saw us from Postgres TV. That would make our day. So thank you again.
Thank you. Bye-bye.